I have this thing that I do before I start my decks. Now you've seen the secret slide, but that's okay. I have this demo that I like to do while everybody's walking in. So I'll do this demo for a few more minutes. And what you'll see is there is 2 windows on the screen. And this is not necessarily a part of the demo, but hopefully it will make you more excited for the demo. What you have over here is what the Connect is seeing. So that's live. That's what the Connect is seeing. Now, if you can imagine that Connect sitting in your living room, maybe hooked up to your Xbox, maybe you're a geek like me and it's hooked up to your personal computer, and somebody happens to walk into your house, as soon as it captures the skeleton, it's going to post it over Web API. It's probably going to crash now that I'm in front of you. But it will take a picture and it will post that picture over Web API directly up here. It is going to crash, and I know why it's going to crash. The good thing is I know why it's going to crash. I forgot one very important step. That's to turn on the compute emulator and the storage emulator. Has anybody attended any sessions this week on Azure Storage or done anything with Azure Storage? There's going to be a lot of hand raising. I take a lot of surveys. Forgive me if you don't like that. I'll run this again. This time it'll work. Is the Connect picking up anything? Of course it won't work. That would be too easy, right? Let me do this. When in doubt, reset, right? Okay. It's letting me down today. Okay. Try one last time. Is the lighting bad on it? No. Okay. What we'll do real quick is kill the power. Is the green light off in the front row? Okay. Okay. What this is, if you've ever seen my weblog, if you haven't, you're forgiven. Oh, I see. There was another instance running. If you've ever seen my weblog, then you know that I'm into Connect programming, and I'm into SignalR programming. And what better way to have fun with 2 of your favorite technologies than to put them together into a completely harebrained idea, right? So one weekend I started thinking to myself, wouldn't it be great if you had something that didn't work with motion sensitivity, so that when your cat jumps off the bar at home and it sets off your alarm and then the cops come to your house, in the States, if that happens, they'll charge you like $500 a visit after 2 or 3 visits. So wouldn't it be great if it only knew when there was a human being in the house? What better way to do that than to read the skeleton? As soon as it tracks the skeleton, it'll take a picture and upload that picture to blob storage, and then post that picture's URL from blob storage over to SignalR. So I can sit in my office and I can watch a website hosted on Windows Azure websites, I might add. And every single time somebody walks into my house to steal something, it'll take a picture, and it'll take a picture like every 3 or 4 seconds. The reason it takes a picture every 3 or 4 seconds is the first time I did this, I was using Service Bus, and that could get kind of expensive, sending lots and lots of images up to the cloud. So I throttled it. Okay? This is an example of one of the ways that you can use SignalR that we'll be talking about during this talk today. Anybody wants to try it out? Just walk in front of the Connect. Seriously, come right up, walk in front of the Connect. Now, here's the caveat. I'm only saving these images to my local storage. Maybe it'll find you. You have to be a little closer, I think. There you go. So these are only being saved to local storage. And I apologize. Some of what you may see today was posted online by one Scott Kate last night. I believe he probably got the video online of my Phoenix talk. Some of the demos that I'm going to do in here, I did at the Phoenix talk, and I've kind of modified them a little bit. That talk was done last week. Anybody go to Code Mash last year in Sandusky, Ohio in January, do the water slides? Anybody there? Good. Then you were not in that talk, so that's good to hear. Okay, so that's awesome. So this will all be new to you. Got a few more minutes. One more minute, actually. No other participants want me to take their picture? Nobody else? Okay, cool. Just so I can prove to you the way that's working, what I'll do is I'll open up this nice product called Cloud Explorer. Not written by Microsoft, but nonetheless a very, very helpful product. And you'll see right here that I've got this Connect Monitor folder. And if I scroll down and start looking at images, there's me in the room last night, testing it out. Apparently I don't know where the new images would be. 622, is that today? No. Here's one. So there's one of the images from today. Is this our latest one? There. That's our unknown guy who took a picture of himself. So this is Cloud Explorer. This is a tool that I use just to make sure that I'm actually posting images. Again, this is only on my local machine. I'm not doing any images up to the cloud, but that's how it works. Just wanted to go ahead and do a quick little demo of what's possible when you have a lot of time on your hands over the weekend to use two of your favorite technologies together. Welcome to the real-time session. The majority of this talk, okay, the entire talk, will be about SignalR. We will talk about SignalR during this talk. When I talked to Damian Edwards about this talk in the States, I actually talked with him about writing the abstract up for the talk. And when I wrote the abstract up for the talk, and I'll do a lot of moving around, hopefully you won't mind. When he did the talk, he asked me to write the abstract for it, so I put in stuff like socket.io, WebSockets, yada, yada, yada. Damon's response to me, he said, well, it's just SignalR. And I said, oh, okay, well, that's even better. So the talk is not going to cycle through all the ways that you can do real-time communications in Microsoft Web technology. A lot of those you can go learn about on your own. This one's going to be solely about SignalR. And just to set your expectations, I'm not going to show you how SignalR works. Okay? When I was at dinner with Damien a few weeks ago, somebody asked him a really intriguing question. One that I've asked him a few times, and I knew what the answer was going to be because he's given me the answer on a couple of occasions already. Somebody asked him, they said, how does SignalR decide what protocol it uses? How does it decide which HTTP persistence layer it sits on top of? Damien's response, look at the code. It's open source. So if you want to learn how SignalR works, that would be my advice to you. I can tell you that I have not done that. I am embarrassingly, admittingly not a SignalR contributor, aside from the fact that I am the SignalR cheerleader. I'm the guy who goes out and talks about how awesome it is. I've already mentioned Damian Edwards. Damian Edwards gave this talk in Orlando. I'm going to give a slightly different talk than Damian did. A, because I'm not as funny as Damian. B, because there's one thing that Damian can get working that I cannot, and that is a handy little tool called WCAT. Anybody familiar with WCAT? Web Capacity Analysis, Stressing, whatever tool. I'm not going to be using that demo today, so I'm not going to show you how to load test SignalR. I would strongly encourage that if you want to learn how to do that, that you go and you watch Damian Edwards' talk of the same title from TechEd North America, because he does go through that pretty exhaustively, and he shows numbers, and he interprets those numbers in a manner far better and far more eloquently than can I. So I'm going to skip that demo today and show you some of my own. And I'm going to bring in some of Damian's demos into this conversation. So with that, I'm going to go ahead and get started. Just so you can get in touch with me later. If we don't have time for questions during the talk, I put my Twitter handle up here. If you don't follow me on Twitter yet, and you decide that you want to after today, I apologize because I tweet constantly. And I'm very accessible on Twitter. So feel free to follow me, ask me questions, whatever. If you have a SignalR question, I would highly encourage that you put the term SignalR in your question, because people like David Fowler and Damian Edwards are going to get to you faster than I am. So just want to point out that we're all very accessible on Twitter. And then there's my email address. Please take a picture of it and put it into as many spam boards as possible so that I'll get loads and loads of email when I get back. Okay? So just want to point out that I am accessible. You can get in touch with me. Just out of curiosity, a couple of shows of hands. How many of you have used SignalR already? Of the hands that are up, how many of you did not like it? Maybe that was going to happen. How many of you want to use SignalR, but it just looks too complicated, or you want to have a good example on how to use it? Okay. How many of you have used Comet? Okay. I've heard Comet compared to SignalR. How many of you have used Socket.io? Okay. This guy, just leave. You're not going to learn anything in here. He's raised his hand every time. I know it. I want to know it. I've used the other stuff. I won't pick on you again, I promise. Really. So with that, I'm just going to go ahead and dive in. About a year ago, I discovered SignalR, and the people that were sitting at the table kind of remembered the vibration, because I literally started shaking. I was like, this is going to change everything. So far, it has not, because it hasn't been exposed enough. There's not enough talking about it. We're talking about it pretty extensively. I know there are a lot of people out there trying it. Because of the fact that it's alpha right now, people aren't really grabbing a hold of it. My advice to you is grab a hold of it in its alpha state, because you can not only see how it evolves, but you'll be able to contribute to its evolution. It is an open source project. Okay? It is wide, wide open. It will be engulfed into the ASP.NET moniker by the time of RTM, when Visual Studio 2012 comes out and the next framework comes out. It will be kind of a part of the model, but it is open source and will always be open source. That's been the commitment from the guys that wrote it, David and Damian. Okay? This was not written in their office time. My joke is they wrote this in their underwear. They wrote this at home. They wrote this in their beds. They wrote this on their couches. They knew that there was a need for this, so they just started working on it. And as they started working on it, they began to find people like myself who got really excited about it, and people unlike myself who got excited about it enough to actually contribute. I just cheerlead. Okay? This is my favorite quote when it comes to talking about SignalR. Any sufficiently advanced technology is indistinguishable from magic. SignalR will defy everything you know about HTTP. In my opinion, it is a game changer. It's been the biggest game changer of the last year. I'm an Azure evangelist, and I see the power of SignalR not only for Azure applications, for middleware applications, for web applications. And I'm going to try to show you implementations of all those today. Like you've just seen, you can use SignalR to build your own home security monitor. There's about 200 lines of code in that, and about 85 lines of that code are Connect monitoring code. Actually, about 185 lines of it. The Connect programming model is complicated. So the SignalR stuff is not. It's so easy when you do it, when you see how it works. It feels like magic. That's why I like to use that quote. Hanselman likes to use that quote with it, too. When he saw my slide deck, he went, I used that quote. I said, well, I promise I stole it from you. You are Hanselman. Okay? Here's our agenda today. And we're not going to have a lot of slides because I have a lot of stuff to show you. I have a lot of demos. I think last count I have 9 demos to show you. So it's going to be a very code-intensive day. Anybody not like that idea? You'd rather see decks? Rather see? Okay, just checking. You're all coders, right? Okay. Here's the agenda. I'm going to do a quick little what is SignalR. Got to do that. The hello world of SignalR. Then I'm going to show you the main components of SignalR. We're going to talk about those semantically in the slide deck. And then I'm going to show you the two major programmatic components of it following the slide deck's closure, which is about 5 slides from now. And those are hubs and connections. I'm going to talk to you about how to host SignalR outside of ASP.NET. Now, as I've already pointed out, and as you may have already heard Hanselman talk about, SignalR is going to become a large part of the overall ASP.NET framework. How many ASP.NET people are in here? Go ahead and have to plug my talk later this afternoon. Have you guys heard of the one ASP.NET idea? This is a part of the one ASP.NET idea. I'll be talking about one ASP.NET at 2, so if you enjoy this talk, come to that one, et cetera, et cetera. So we're going to go through some of that, and you'll see another demo, a very far simpler demo of SignalR within that talk. But the nice thing is, you don't need ASP.NET to host SignalR, and I'm going to show you how you can host it on your own. If you were in Syed Hashimi's talk on Web API yesterday, there's a similar piece of functionality in Web API. You can host it yourself outside of ASP.NET. Same sort of idea. You can see that a lot of the technologies in the ASP.NET underpinning are basically borrowing ideas and reusing ideas from one another. You'll just see that become more and more evident as we move on. In addition to being able to host outside of ASP.NET, you're going to have the ability to do native client implementations. There are all kinds of different clients for SignalR, not just the HTML client that you see done with jQuery. Yes, that is the most practical one. The idea behind SignalR was that you wanted to give real-time web communications. But you can do non-web communications too, and I'm going to go into that today. One of the major questions that people have had about SignalR is this concept of scaling it out, especially in the era of Windows Azure websites, cloud services, and that kind of thing. If you have one server and your performance is great, and then you start to get a lot of customers, and now you need 10 servers, usually what you have to do is you have to have some sort of a backplane for your session. How many of you have used session before, and then you went over to a web farm environment and you realized, oh boy, I have to do something different. I have to use like a database to like manage all my session state. Okay? SignalR is very much the same way. You have to do something different to make SignalR scale out across multiple servers or in a farm environment. I'm going to show you how to do that today. The first 3 times I gave a talk on SignalR, that was the #1 question that I got. So I figured I better include that as part of the conversation. I'm going to show you 2 methods of doing that today. And I tried really, really, really hard to convince Clemens Vasters to come in for the last 5 minutes of the talk, because that's when we're going to show an implementation that he wrote that uses Service Bus as a backplane. But he's giving a talk at the same time, and he wants to use up his whole time. So he's not going to make a guest appearance today. My apologies. I bribed him, but it just didn't work out. And then we're going to have a little bit of fun. One of the having fun areas is the Connect Monitor, which I wrote a much longer version of originally that actually used Clemens' Service Bus. And I blogged about it. One thing that I didn't put up on the board was my blog address. It's just like my Twitter handle. I'm really creative with my URLs. It's bradygaster.com. Okay, so if you go to bradygaster.com, you can see kind of a video of how the original Connect Monitor works. I've really stripped it down and made it a lot more lightweight. I've done that because my focus is Windows Azure websites, and I wanted to make it work in Windows Azure websites. So, all that being said, I'm going to show you the different components of SignalR. Kind of the different major ideas in SignalR. I promise you the slides are almost over. Obviously, the first one is the client. You want to have the ability to connect your client technology, whatever it may be, to the real-time functionality you're going to get with SignalR. So what's happened is that not only David and Damien, but a lot of other contributors have written clients that will work with SignalR. You probably won't find one up here that you need. I mean, we don't have a PowerShell client, but not a PowerShell, but a Power Builder client. But maybe one day, if you want to write it, you can write it and submit it to GitHub. But going from left to right, you'll see that there's a jQuery. That's pretty obvious. SignalR runs as a jQuery plugin. How many of you use jQuery? You're 50% of the way to understanding how SignalR works already. This is going to be cake. Okay? There's obviously a native .NET client. That's how I was calling SignalR from this from the Connect code that I had written. All right? So there's a way that you can use SignalR from within native .NET code. There's a WP7 and a WP7.5 client for it. So if you want to do Windows Phone apps, you can do that in here. Somebody has worked on an iOS client. It hasn't actually been brought into the main SignalR GitHub repo yet. It lives off in its own repo, but there is one. So if you're writing native iOS applications, you can make use of SignalR yourself. Just want to point that out. Yes, there is a Silverlight version of it. We know that there are going to be a lot of people still using Silverlight out there. Just out of curiosity, Silverlight? Cool, good to hear. So there's a Silverlight client for it. So if you want to get into that world, if you want to go ahead and make real-time communication with SignalR, you'll be able to do that. WinRT. There is already a WinRT client for it. So if you want to do this kind of stuff on Windows 8, if you want to start doing Metro applications that use real-time communications, you can do that using SignalR too. Another show of hands. How many of you have tried the Metro stuff already, WinRT? Anybody? Have you been to some sessions this week? Pretty good sessions? Nice. Chris Mayo does a pretty good workshop. You should check that out. I need to go to it myself. I'm a baby at WinRT. I want to get into it a little bit deeper. And then all the way on the far right, you'll see something that really shows the adoption of SignalR. That there's an Android implementation of it through Mono. What does that mean? That means Miguel saw it and thought it was cool enough to bring it into Mono. That's a big deal. That should basically be a stamp of approval for you, because Miguel really doesn't just take in anything. So it's nice when people of that caliber see something that was developed by the open source community and bring it into their overall, not competitive, but complementary .NET implementation. So that does exist. So there are all the clients. Have you seen them that you use that we haven't covered yet? Windows CE maybe? Anybody? Okay. If it's not there, you can write it. Obviously, you have the native .NET one, so you could probably bring some of those classes in, reuse them, and go crazy. Or as my friend TechEd likes to say, you can party in your own way if you want to. All right. Hosts. Like I've already mentioned, you can host SignalR. Right now, there are 3 main hosts. There's the ASP.NET host. Kind of not surprising. It's a part of the ASP.NET framework. There's an OWIN host, the Open Web Interface for .NET. If I've misquoted that acronym, I apologize. You'll see OWIN grow and grow and grow in popularity. Anybody ever heard of Nancy effects? It's like a different way of doing like server-side communications, almost like a handler, but better. Well, you can host SignalR in the same way. What I'm going to show you today is the third way, which is self-hosting. From what Damien has said, he actually asked me, he said, hey, if you could change your self-host to use the OWIN host, that would be awesome. My response to him was, hey, I'm traveling to like 5 countries over the next 3 weeks, so that's like not going to happen. All right? So you'll be seeing a self-host demo. It's not that it's a bad thing or a good thing. It's just like he's trying to move everybody towards the more and more and more open implementations. And OWIN, the O, it's open. So we want to go in that direction. And then the last thing that I've talked about are what we call backplanes. The first one of those, SQL, that was the first one. Just sort of like when you see, like the SQL backplane for doing session state. You want to take your session, have a web farm, session key, blah, blah, blah. It's the same sort of idea. And that one was the earliest one that was written to scale out SignalR. I've heard that the support for that is sort of waning. And it's waning because of the other 2 implementations being so much more performant and so much more popular in the web development community. Once you get into this world, you're going to need fast throughput. Okay, SignalR is very, very fast. I'm going to give you some numbers in just a second. The SQL implementation is not as fast as the other 2 implementations are. And it's not that the SQL implementation is going to be deprecated, but it's not going to be built on. Okay, so at this point, like SQL, yay, nay. If it doesn't work yet, it will work eventually because we'll probably have enough requests that somebody will augment it with the new scaling capabilities. But the 2 that everybody really recommend are Redis and Service Bus. And I'm definitely going to show you the Redis implementation today. And I'm going to try really hard to show you the Service Bus implementation, but time just might not allow. I'm going to try to show you both of those. The one that Damien demonstrated in Orlando was the Redis implementation, and I can tell you that it will take you about 5 minutes to get that set up, and I'll show you how to do it. It'll take you about 5 minutes to get the Service Bus implementation set up as well, but there's a caveat, and I'll talk about that caveat when we get to that part of the conversation. So these are the main components. You got your clients, you got your hosts, you got your backplanes. Kind of see what's happening here? SignalR is evolving as its own beast. All right? It's not in a 1.0 phase yet. but it will be. Those numbers that I promised that I would give you. Right now, Damien and David have said that they've done some benchmarks, and they can do 40,000 persistent connections with SignalR, and the web server CPU utilization will be at around 40%. So imagine your web server churning along at 40% with 40,000 users. Now remember, these aren't one-hit wonder users. These aren't request response users. These are users whose connections are constantly open to the web server. Constantly open, 40,000. They've said that by the end of the year, when they release their 1.0 version of the framework, their personal goal is 100,000. So imagine being able to have 100,000 concurrently connected, persisted users looking at your site. Imagine what you could do with that power. These are real-time communications. Okay? Let's just jump right in. Let's just go ahead and jump right in. So those are really all the numbers that I wanted to show you and all the high-level stuff. And the first thing I'm going to do is type the right command. I'm going to run this as an administrator because I'm going to be doing some hairy stuff today. And I'm going to open up this TEE12 solution. And you'll see that there are going to be a lot of solution folders in here. That's because we have a lot of demos to do. And really quickly, what I'm going to go do is set my startup project to be whatever project I have selected at that time. All right, so I told you that the first thing we're going to talk about are the basic building blocks of doing something with SignalR. The most basic of all of those building blocks is a SignalR hub. And think about what a hub is. In the center of a wheel, there's a hub. You have all these spokes that come in. Whenever you send something into the hub, you have the capability of sending that message out through all those spokes to all the clients instantaneously. So you have a hub that sits on the server, and that hub is going to send messages out to the clients. Sounds a little weird, all right? We'll take a look at how hard it is. So here we have a class. It's a simple class, and we're calling it HitCounterHub. That class inherits from another class that lives in the SignalR runtime, or the framework, called signalr.hubs.hub. It's an abstract class. You inherit from it. The nice thing is when you type override in the window, there's really nothing to override. There's not a lot of stuff to override. What there are a lot of different properties. And we're not going to use a lot of these properties today, but I'll go ahead and do base. You're going to see a couple of things here. Oh, let me do one real quick thing. I haven't turned on Zoom it yet. So I'm going to see base right here, and I'm going to zoom in on that so that you can kind of see everything. Maybe not. So you'll see caller and clients and contact and groups. What do you think caller is? Give me a guess. The initiating party. It's a great way to put it. Caller is the client that made the call to the server to call the add hit method. Okay? That's who's going to call the server. So if I were to basically say base.caller.whatever, I'm going to be calling methods on the guy who called me. Okay? Oh. Clients, the one just beneath it, apparently I can't scroll down when I'm zoomed in. Clients, anybody want to take a wild guess what that is except for this guy because he knows everything already? Anybody else? Come on, you already know what it is. It's all the clients that are currently connected to that hub. Everybody. So if you have 100,000 different clients connected to this hub, and you make a call to clients, you're calling every client that's connected. At this point, you should be going, not going to work. He's going to have a major demo fail in about 5 minutes. Nobody believes this is possible. Context is going to be basically the context of the call, and then groups. Damien and David realized, they said, well, there's probably the good possibility that you're going to have groups of clients. You're going to have some admins. You're going to have some anonymous people. You're going to have different groups of clients that are going to be connecting. So we want to give you the ability to call methods on the clients that we group into different groups. So that functionality also exists. We won't get into that too much today, but what I'm really going to do is to kind of show you how clients works. Now what I'll do here is I'll go ahead and comment that code out, and what I'll show you is, you should see something right there. When I go to clients and I hit a dot, what kind of an object is clients? It's a dynamic. Okay? How many of you can't stand the idea of dynamics in .NET? Oh, a few more people than normal. You're in trouble. Does anybody know who John Skeet is? You ever heard the name John Skeet? Very, very big time MVP. He knows a lot about a lot. Very well respected guy. Okay. His hand was the one hand that went up when I asked that question at CodeMash. I had never met him before. Okay. So I spent an hour calling him Dynamic Guy. Every time I would do an example where I used a dynamic, I would turn to him and say, "You're not going to like this. Sorry." Then I'll go on with my demo. Well, at the end of it, one of my colleagues comes up to me and he goes, "Hey, that guy you were teasing, his name's John Skeet." I was like, oh boy. Because John is a very, very well-respected guy, and I was afraid that I've offended him. We had some blogs back and forth. We teased each other. It was all good. So there's no bad blood there. But there's going to be a lot of dynamic stuff in SignalR. You'll see why later on. And believe me, when I discovered that, I got a little bit annoyed because I was a little hesitant to use dynamics in my .NET programming, even though I had Ruby friends that told me that it was the sun and the moon and the answer to all of their woes. It makes sense once you do it in SignalR. The power of dynamics actually begins to make sense in how you can use it. And I'll show you how that would work today. I'm going to escape and back out of here. Now what you'll see here is that I have a very simple class, hit counter hub. I've decorated it with an attribute. I'll show you the point of that attribute in just a moment once we get to the jQuery code. But that's the extent of it. You can basically extend the hub class, create methods on that hub class, make use of any of the properties that live on the abstract hub class, and party however you want. Now when you say clients.method, that looks a little weird. How am I going to run that method on the client? How's that going to work? I'll show you that real quick. Hit counter hub. And what I'm going to do is I'm going to shrink this window so we can see all this stuff. You'll see that I have 3 JavaScript files that I import. This is our hit counter page. Notice the extension, HTM. You could do this in a PHP file too if you wanted to, because it all happens on the client. As you'll see in just a moment, everything you're going to do is going to make a call through jQuery. How many of you in like the .NET 1.1.2.0 era, you set a web reference? You remember setting a web reference and you get a proxy file? This is very much like that. This works exactly the same way, but your proxy code is dynamically generated jQuery code, and it lives directly on your client, directly on your web client. So the first thing you do is you import jQuery. Second thing that you do is you import the jQuery SignalR file, and that file you get whenever you do a install package SignalR from NuGet. You can get this from NuGet. It's free. It's widely available. You can party with it without very much effort at all. And just to show you the answer to that question, I can find that set of code in here. See this part where it says signalr.transports? Notice the order that he goes through. He goes through WebSockets. So if you are on IIS 8 or IE10 or Chrome or any other browser/server that will support WebSockets, guess what? You're running WebSockets when you do SignalR. If you scroll down, you'll see that option 2 is server-sent events. If your server and your client support the concept of server-sent events, that's what SignalR is going to fall back to. If not, it's going to fall back to forever frame. And 9 times out of 10, until IE10 is ruling the world and IIS 8 is ruling the world, this is probably what you're going to fall back to is long polling. The idea behind long polling is the client makes a request and it holds on to it until the server's done. The client just, what you got? And the server waits until he has something. He sends a response down, and then the client goes, what you got? Again. So it's basically the same code that you would have to write that would probably drive you and your boss crazy. Don't worry about it. They've taken care of it for you. What you'll see here, this is proving something. SignalR is an abstraction on top of all of those transport layers. If you write to SignalR, it doesn't matter what those transport layers are. There's this European colleague of mine, Martin Bayau. I don't know if he's in the room. If he is, I probably just butchered his name. Martin did something almost sacrilegious. He actually wrote a SignalR implementation that sits atop Socket.io. So he added a member to this guy. So he actually put SignalR right on top of Node. Pretty groovy. He did that because, again, SignalR is an open source framework, and you can add your own stuff to it if you want to. Okay. That's actually this script right here, and all that is the SignalR plugin for jQuery. And that's what's going to do all the work and do all the proxying. This one right here, SignalR/hubs, I've pointed out that there are two ways that you can do SignalR. One is with a hub and one is with a connection. I'm going to show you a connection example after this example. When you're using a connection, you can omit that call. What that call will do is it will go out to the server, and the server will iterate over all the classes in its assembly, find any class that extends hub, and then create a proxy for it dynamically using jQuery. Pretty cool, huh? Pretty neat so far? Now I've got some pretty simple Metro-looking UI stuff for you, and then we get into the jQuery code. In my page load, I'm going to declare a variable called hub. And you see what I do? I just say .connection, and I think we can even have IntelliSense in there. .connection, because you get that with your Visual Studio 2012. You will not get this in because it's going to be dynamically interpreted. Now, remember before when I mentioned this hub name attribute? Whatever I put in that hub name attribute, in this case I put hit counter in there, that is what I'm going to put right here. And remember what that SignalR hubs guy is going to do is it's going to build a proxy for every hub inheritor in your assembly. It's going to build one dynamically for you and just pass it down the wire. So whenever I run this, it's going to basically give me the name, and I can just ask for it by name. And I'll do Q&A at the end, if that's okay with everybody. I'll stick around. I have 4 hours till my next talk. If you have any questions, again, I'll just hang out afterwards, but we have a lot of demos. Hopefully I'll answer your questions by the time we get to the end. You'll see it. Now, what I'm doing here is I'm using jQuery's extend functionality, which I learned from Damien. And the first argument that I pass in is hub. All right? So I pass in hub here, and then I give it object notation. So I'm actually building an object and passing it in, or extending that object and passing it in. And you'll see that I've got a method here called show hit count. So what I'm saying is, whenever the server calls my show hit count method, me being the hub, this is what I'm going to do. I'm just going to update some HTML. How far has this defied everything that you know about web technology so far? Okay? Pretty like out of the box. You're like, this is never going to work. Does anybody remember push technology from like 1998? Okay, this is that, but it works real well. All right. Okay, so we're going to update some HTML in basically our method handler for all intents and purposes. And then down below, we're going to call .connection, .hub, .start, and we're going to pass in a function callback. Let me show you why you would do that. If I were to take this call and take it out of here, do it like this, that connection.hub.start uses another popular technology in the Damien and David crowd. It uses all the async await stuff. Everything in SignalR is going to be asynchronous. Some of you probably have heard the rumors about how IIS can only have so many transactions in a second, and it'll blow up, and the threads will blah, 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 blah. Okay, well, all the stuff in SignalR is going to use the asynchronous versions of those things. So none of the calls that you're going to be making to the server are going to block any of the other calls. That's why you can get 40,000 simultaneous connections. The interesting thing about that, Damien tells me that asynchronous functionality has been resident in the ASP.NET framework since it was first released. They're just exposing it in a really friendly way. So this just makes something that's previously really hard to do, really easy to do. Well, this start method is an asynchronous method. I don't know how long it's going to take it to run. So if I left the code like this, whenever I get to the hub.addHit method, there's a pretty good possibility that I have not instantiated a connection back to the server with my connection. That's why I put it in here as a callback. Okay? Because whenever it makes the connection, it's going to then run some functionality. It's going to call hub.addHit. Now, just to reflect on this for a second, not using system.reflection, but so semantically reflect on this for a second. We have this addHit method on the client's hub variable. That's going to call this. This is going to run, and we're going to call the showHitCount method on the clients. That is going to run this. Sound fun? Let's party. I'm going to set this as the start page, and I'm going to run it. Now, you've seen a hit counter before, right? Back in like 95 when Java was cool. Now, you see I've got 2 hits, I've got 3 hits, I've got 4 hits. Yeah, that's great, Brady. See what's happening? Okay. All right. If that's not cool, you're asleep. All right? Raise your hand if you dare say that's not cool. I'll get something to throw. Okay. All right, so that's a hub. That's how a hub works. Pretty impressive so far? Okay, well, I'm going to go ahead and go into connections. First thing I'll open up here is this user counter connection. Well, there's this really popular website out there that you've probably never been to called Stack Overflow, right? Okay, you've been to Stack Overflow before. And you see over in the sidebar, it says there are 7,922 people currently logged on. What you don't see is that when somebody else logs on, that number go up or that number go down. We're going to do that next. We're going to do an active user counter in SignalR. Now, I'm a big fan of having simple examples to kind of get your feet wet. Simple examples to make you go, I think I could use this in my own environment. And then I'm going to dive in and show you some crazy, stupid examples that are really, really long-winded, a little bit more code, a little bit more realistic, and a little bit more fun. So we're going to do all that. This is the last demo where I'll actually go at this pace. I kick it into high gear after this demo. Now, in this particular guy, I've got a user counter connection. Okay? So I've got user counter connection. It inherits from persistent connection. Okay? I've got a user count variable right here. And you'll see that I've got onConnected async. That's an override. The connection class is a little bit more low level than the hub, a little bit more strict. You can do a little bit more with it, but it's a little bit, you have to have a little bit more work you got to do. Right? If I open this up, you're going to see I'm going to add one to the number. I'm going to do some debug here. And then I'm going to call this .connection.broadcast. When I call broadcast, that's kind of the same thing as me saying clients.do-something. But instead of saying clients.do-something and getting into dynamic land and upsetting some of you, I'm going to call broadcast, and whatever I broadcast is going to be sent out to all those clients. Same sort of idea. Now, how many of you are looking at the second method? You should be. Because it's on disconnected async. And those of you who are thinking ahead are probably thinking to yourselves, do you mean to tell me that that server class is going to know when somebody closes the web browser? Yes. That's what I'm telling you. So you're going to see that happen. Now, the code for that method is pretty much exactly the same thing. I'm going to decrement it. I'm going to debug it. I'm going to do a broadcast. And then I'm going to call the base. I always call the base. Just a religious thing with me. Now, before when I said that you don't have to include a reference to the hubs guy, that means there's one less step that you have to do when you do a connection on the client. But guess what? There's one extra step that you have to do when you use a connection on the server. You have to route it. How many of you have done MVC routes or Web API routes? They're exactly the same in SignalR. It's exactly the same deal. You basically just say routetable.routes.map connection, pass in a generic argument that is the type of the connection that you want to route. Then you give it a URL or a URL base, kind of where you want to land on, a route. So whenever I call user counter, I'm making a connection to that particular connection on the server side. I need some water. Too much espresso this morning. Okay? So you got to route it. So if you're taking notes, when you make a hub, you have to include SignalR hubs on the client. When you're making a connection, you don't. But when you're making a connection, you have to route the connection in your global ASAX or in your app start or wherever you're going to do your work. Okay? Now we'll take a look at the client-side code, which is not very exciting. First thing we do, we import jQuery. We import jQuery SignalR. If any of you are wondering if there's like a Dojo implementation of SignalR or a prototype implementation of SignalR, not that I know of at this time. It really only lives on top of jQuery. But again, SignalR is an open source framework. If you want to do that, go crazy. Party with it all day long. Write your own Dojo implementation of SignalR. That many more people will want to use it. You will see that I do not call SignalR/hubs in here, and that's because I'm using a connection and I've routed it in my global ASAX. So I don't need that dynamic proxy. I'm just going to route directly to my connection. And now I'm going to scroll down, and it's very similar syntax. I declare a variable, but remember before I would say connection.hubName. In this case, I'm just going to say connection, and I'm going to pass in the route. So whatever I type into my global ASAX, I'm going to get right here. I'm going to put it right here as well. Some of you may not like the fact that there appears to be some magic string trickery. I would like to ask you a question. How many times are you the guy writing the code on the client and not writing the code on the middleware or the server? Probably this many. How many times out of the ones that you are is the guy not within screaming distance, so you can tell him the name of the route? You have to forgive the string trickery. That's how it works for now. That's also how routes work for now. It's really not that painful. Okay? So just forgive that if you don't like it. Now, on the client, when you're using broadcast from a SignalR connection class, the client equivalent of the handler is called received. So I would say c.received. Now, remember from our connection, I'm going to be passing in a number. That could be anything I wanted. We'll have a demo here in a moment where I actually use a dynamic class as a parameter or an argument. You'll see how we can go crazy with that as well. In this case, we're just taking the count, and we're updating some HTML down below, and then I'm calling c.start. C.start will open up the connection, and you'll be able to make calls back and forth. All right, let's run it. Now I'm going to run this code. There is one user online now. Great. There are 2 users online now. There are 3 users online now. And I can tell you that of all the demos, the potential for this one failing is the highest. Let's see. Cool. Neat, huh? Okay. Remember when I talked about the server side, how you can do native client implementations and all that? That stuff exists in the native implementations as well. So if you wanted to do disconnect handling and whatnot in your native client code or your WP7 code, you can do that as well. Now, let's get real world. Let's show you how you can use this in a real application. Not really, but you know. So let's say you have a situation where you want to communicate the time on your server to a series of clients so that they're all synchronized. Why would you want to do that? Because you'd be stealing the crown jewels, and you want to make sure that all your watches are synchronized. So you want to, make sure you're all in the right place at the right time. Okay? You guys seen those movies, right? Tom Cruise? Okay, cool. All right. So what I'll do here is I'll open up Time Hub. Not very cool, not a very sexy idea, but I've got a start timer method. You'll see that I'm not decorating this hub with an attribute. I'm just going to call it from Time Hub. Okay? I start a timer, and whenever that timer lapses, I'm going to log something, and I'm going to say clients.showtime. That's really the only SignalR related fun in this class. I'm going to call showtime on all the clients. Now this is my hub. This is the hosting part. What I'm going to do is I'm going to show you how to host this hub from a console application, and then how to call that hub from a web client. So you'll be calling a SignalR hub that doesn't live on a web server. Pretty trippy, huh? Let's go ahead and take a peek at how we're going to do that. So here's our time hub server. You'll see that what I do is create a new path on my computer. Remember when I started up as admin? This is one of the reasons why. You have to start up as admin to open a port from Studio. Just want to point that out. So if you try and do this at home and it gives you an access denied error, close Studio, reopen it as admin, you'll be partying. Okay? You'll be good to go. All right, now what I've got here, I'm creating a signalr.hosting.self server just to show you where that lives. It's right there. It is a reference that I pulled in from NuGet. Signalr.hosting.self is one of the many NuGet packages related to SignalR that you can just bring down and use all day long. Okay? It's free, widely available, and open source. So I declare a new instance of that server, and then I call start. The start method in here basically just starts my server up. Then I'm going to give it a context, and I'm just showing you this. Since this server and the hub that I'm going to be calling live in the same assembly, this line of code is extraneous, retentive, if you will. But I just want to show you this because if you wanted to add other hubs from other assemblies into your mapping, this is how you would do it. So take a picture now if you think you might want to do this. The code's already in GitHub, so you can download it later. So I just want to point that out. And then down below, we're going to call SignalR self-hosting server.map-hubs. That should give you an idea as to what happens in the ASP.NET host. Remember before when I told you how that, like calling that one dynamic guy is going to give you all the different hubs in proxy format? That's because they call the map hubs guy on the server, and whatever they come up with, they just serialize to jQuery and spew that down the wire. So that's what we do there. We just kind of map all of our hubs within our server. And then I have this console client right here. I'm going to open it up, and you'll see that I'm declaring a new instance of this guy. I'm calling start. And I've got your traditional tell me what to do code. As soon as somebody hits enter, we're going to stop it. I want to make sure that the right project is selected. I'm going to hit Control F5. Now we've got a running server. We've just hosted SignalR in a console app. Okay? So that's running. Now what I'll do is I'll open up this web client, close all but this, and you'll see one very particular thing that I do here. Localhost 17 SignalR hubs rather than just / SignalR hubs. That's me running this site in IIS Express and making a call to another server that's got my hub hosted so I can basically run those servers outside out of process. Okay? I'm going to run this in a console application. This, again, not a very sexy demo. I just want to show you that this is one of the things that you can do is host your hubs in a console application and party with them in your client. Now down below, I'm going to call time hub. That's basically just the name of my hub. I'm going to extend the method. Whenever I get the time from the server, I'm just going to throw it into an HTML element called clock. This call right here was required prior to the 5.1 release, or the 051 release of SignalR. I don't know if I still need it. Damien has told me that I don't. I don't trust him. So I'm just leaving it in for now, because I know that it works. So we don't want a demo fail. So what I'll do here is I'll show you this guy, and you see that it says server running. And now I'm going to, since I'm in my web client guy, I'm going to run this guy. And I'm going to open up this hub as well. You see what's going on there? It says sending stuff to the client, sending stuff to the client, sending stuff to the client. Let me open another client. See how it says client connected right here? Let me open another client. We just have another client connected, and now we have all three guys with the same time. Now we can steal the Queen's jewels. And we'll be right on time. Let me show you what happens when I kill the server. Timer stopped. I did have a question the other day that completely stumped me. Now, if you rerun your server, will all the clocks start back up again? No, they won't, because the connection has been killed. Now, I could write some JavaScript code on my client to try to reconnect however often, and once I make a connection, I could party. But right now, dead. Killed the server, killed the clients. Cool. So, God forbid they were to find where our server is running as we're trying to steal the Queen's jewels, and then we will all be in deep trouble. I have no idea what time it is. Now, that's all well and good. Where would I ever want to host SignalR all by itself? Where would I want to do that outside of IIS? You guys remember my job title? Windows Azure Technical Evangelist. This is the part where you get to see how to host SignalR in an Azure worker role. The reason that I went through all that crazy abstraction to write this time server is because I have this project right here. I have an Azure project with a worker role. When the onStart method is called, I start that server. When the onStop method is called, when somebody shuts down this Azure process, I'm going to stop that server. Now what I'm going to do is I'm going to right-click my compute emulator icon, and I'm going to show the compute emulator so that you can see the cloud service running locally in my computer. And what I'll do is I'll select the right project, which is this project, and I will hit Control F5. And you'll see that we deploy that that worker role into my local compute emulator. If you deploy this as a cloud service, you've got a time server running out in Azure. Same sort of idea. If I expand this guy so you can see the trace, now the trace will be a little bit more slow than it is in the console app. I'm going to go ahead and clear the logs. That's just showing me that it's awake. I'm going to go back here to the web client, and I'm going to launch this guy. And I'll switch over here. And like I said, the trace will be a little bit slower than it will over the other one, but you'll see that I've got a client connected. And just like before, we're running. Neat, huh? So that's how you host SignalR in the cloud. Okay? Has anybody ever heard of PubSub? Publish, subscribe? Is this beginning to look like publish, subscribe? It's kind of what it is. We're going to get into that next. I'm going to show you more implementations that are going to kind of show you how SignalR is basically a very lightweight pub-sub layer that you can use in your own application architectures. And the way I'm going to show you that is when we get into the native stuff. Now, a couple of months ago, I went to work for a big company in Washington State. This one. And when I went to work for them, right after I went to work for them, I started to notice that my site was going down a lot. It started to crash. Couldn't figure out why. It's probably the people that weren't happy that I went there, trying to crash my site or something. But if you're an evangelist, it's really not a good idea for your site to be going up and down. And if you're obsessive about your site, it's really, really bad for your site to be going up and down. So I wrote a site monitor. I did it using SignalR. And I'm going to show you how that site monitor works today. Like before, I've got a core product, a core package right here. And in this package, I have a couple of interfaces, and a server. I'll show you the first one, iHub configuration. Now, what this guy does, basically, is he's going to get the URL, that GitHub containing site URL, is going to give back the server, the hosting executable. It's going to give that server the URL that I can talk to the hub at. So I'm going to have a hub that lives on a website, maybe hosted in Azure, maybe hosted in Azure websites, maybe hosted on my local server, whatever. So I'm going to have a web server hosted SignalR hub. And I'm going to provide the URL to the calling code through that method. I've also got a log method, as I might want to log here, there, everywhere, depending on what sort of implementation I've got. Okay? Zoom back out. I've got a second service, iSite URL repository. Okay, I'm monitoring websites here. So I've got one method that I call to get a list of strings that are all the URLs. I've got one method that I call to add URLs to the collection, whatever it may be. And I've got another method that I can remove sites from my collection, wherever it may be. Not too complicated. Be using DI in this example. not really using a DI container. I'm just newing up my guy and passing in what I want for that particular implementation. Okay. I'll close those down, and here's my server class. As promised, here is our constructor. Pass in those two services. And you'll see two guys right here, hub connection. That is a SignalR hub connection, signalr.client.hubs.hub connection. This is another package that you can get from NuGet called signalr.client. My advice is just go out to NuGet.org, do a search for SignalR, and then go, wow, there's a lot of stuff I can do with this. Okay? One of those is the client piece, and that's what we're going to look at right now. So there's a hub connection, and here's an iHub proxy. Sort of what I do is I'm going to make a connection using that first guy. I'm going to instantiate a connection to the server. And then I'm going to get back a proxy for the particular hub that I want to work with. Let's take a look at the stop method. I'm just going to stop a timer. And in the run method, I'm going to create a timer. I'm going to get a URL using that first service. Then I'm going to instantiate a connection, passing in that URL. And I'm going to call create proxy, and that will give me back the site monitor notification hub guy. I'll flip over and show you that hub in just a moment, but then things are going to get interesting. Okay, so I'm just going to walk through this code real quickly. All this code that you're looking at is, I've put it in GitHub, and you can download it. I'll show you the URL for that later on. But there are demos for how to do all this stuff in the SignalR wiki, which is also on GitHub. Just want to point that out. So then I create a timer. And in the elapsed event of that timer, what I'm going to do is to try to download a string from whatever URL that I'm looking at that time. So I'm just going to iterate through my URLs and try and download code from those URLs. And if for whatever reason I have an exception fire, such as a 404 or a 500 or a site's not alive error, I'm going to basically set the result variable, which I've got right here, equal to false. Pretty simple. Now this is where you get into the SignalR stuff again. Hub.invoke. And I pass in the name of the method that I want to invoke on the hub. So this server application will be making outbound calls to a SignalR hub that is loaded into a website. And I'll open that hub up right now. That hub lives right here. I'll go into hubs. And you'll see this guy, receive monitor update. Look at the parameter type. I'm passing in whatever I want. Passing in whatever I want. I'll give you an idea of the structure there. See how I've got a newed up object here that's an anonymous type? I'm basically providing two arguments. You guys have seen like JSON code and jQuery. You can just create your own objects and go crazy with them. That's what I'm doing here. I'm just creating an anonymous type. I'm passing it two pieces of information. One of those pieces of information is the URL that I just hit or tried to hit. The second piece of information is whether it was dead or alive, whether the site was up or down. The result equals true or false. Then I'm calling timer.start. That means I'm going to call this guy. So the server is going to call receive monitor update. The server is then going to call a method on all the clients called notify site status. I'll show you what that looks like. Again, we've got our hubs, JSON code, jQuery, the whole nine. As before, we instantiate a connection to our hub. And then here's our first method handler that we deal with, notify site status. Basically what we're doing here is we're creating squares on the screen. Those squares are either, can you guess what colors? Green or red. And they're yellow whenever we're actually adding the site to the guy, to the collection. I'm going to scroll down a little bit further. And this is when we get into the pub sub idea. What you'll see right here is that I've also got two other handlers on the client. Notify site removed and notify site added. And notify site added, what I'm doing is I'm saying the server told me to add some function, told me to add a site. So I'm going to basically add a site on the client. The server told me to remove a site, so I'm going to remove a site on the client. That's again the SignalR client responding to activity from the hub. Okay? Add site to GUI, remove site from GUI. Now what you'll see here is this guy and this guy are going to call the client. Now I've also got two other interesting methods right here, add site and remove site. Add site and remove site are going to be called from the client. So I've got a small little lightweight client application that I wake up and I type in add a site, remove a site. Okay? Whenever I do that, I make a call to the SignalR hub. And what the SignalR hub does is very interesting. It calls another method on clients.siteAdded. But you didn't see me handle site added or site removed in my jQuery code. That's because I handled those two events in my server-side code. Where I do that is right down here. On the event site added, which is going to pass me a string. I use a lambdas here, and this is just a string. I'm going to call the add method on my site repository, which you saw is the service that I passed into the constructor earlier. Then I'm going to call another method on the hub. So the user adds a site to a collection. The server responds. Then the server says, hey, whenever you tell me to add a site, I want you to send a method back to the hub. This is the pub sub part. This is the client, the web client, subscribing to a couple of different events, and the server that's hosting it subscribing to a couple of different events, and them responding whenever things happen in that hub. The hub literally ties everything together all the time. Okay? And then I call start.wait. That's part of the TPL. It's part of task await. You guys saw on the jQuery client when I call start and I pass in a callback. That's the same sort of thing, but you're doing it in the native code here. You're calling start and then you're waiting for that start method to actually execute. Just want to point that out. Okay. So what I'll do now is close all that down. Now here's the interesting order of events. I'm going to have to run the web first. Why do I have to run the web first? That's where the hub is hosted. So I'm hosting the hub in ASP.NET now. And you see that I've got this site URL guy. Now I've got a console client here. In my program class, I've got a static site repository implementation. And I've got the console app configuration. Now my console app configuration guy, all he does is he reads a setting from the configuration settings. And when he logs, he just logs to the console. Not a big deal. Okay? Not a big deal at all. The static site repository just has a list of strings. And I add and remove guys from that list of strings. And whenever the add method is called, I change the color to one color. And when the remove method is called, I change the color to another color. Not a big deal. Not so hot yet. But again, I've already got my hub hosted out here, but I don't have anybody to call that hub. So I'm going to run this console client right here. Is that the right one? Yeah, it's the right one. So I've got that called. So what I'll do here is I'll type in HTTP, bradygaster.com, and call that. And you'll see the site added over on the server side. And the next time it pings all the sites, it gets all the sites. If I go over here and I type in somebadaddress.com, you'll see that it's going to go out and try and check it, and it's not there. I'll take this guy. Put him right. Oh, of course I'm going to get an error. That would be too easy. But you'll see that I've got all these guys. If I hit refresh, whenever this pings again, it's going to come back. And if I hit delete, you'll see that the site got removed. Okay? Now, when the site got removed, it called the SignalR hub. The SignalR hub called the jQuery code. The jQuery code removed the guy from the client on the fly. Is that pretty neat? You guys like that so far? You see this in your own applications? Okay. Now, remember my job title. I'm an Azure evangelist. Okay? I'm going to run this website again, and this time I'm going to go down here, and you'll see that I've got a worker role, and in my worker role, I'm actually going to use table storage in my local table storage account to host my list of URLs. and I'm going to use a worker role hub configuration, and that's just going to read from the cloud configuration file rather than the app configuration file. No different. Same sort of idea. This demo will go pretty quick because you've already seen it once. I'm going to select the Azure project, and I'm going to run it. And you'll see my deployment come up over here in just a moment. And that's basically a worker role. And it's hosted over there. And you'll see that I've already got guys loaded in. And you can see that calling over here. If I were to do HTTP, just make sure the TechEd site is up. Because I know you guys want to do my evals. Click add site. Of course, this is probably not going to work now. There we go. MS TechEd is up. And you'll see that I've already had it in there. So it was already in there. Let's see if North America is still up. Add site. Yep, North America. There we go. So you see that this site is down, which is interesting because it's this site. Okay, we'll call that a demo fail. I'll give you that one. All right. So that's all great. Okay. Pretty neat so far? So you've seen like how we can basically use abstractions to host SignalR wherever we want to. Now the next thing I'm going to do is I'm going to show you the pinnacle of all ways that you can use SignalR. And that's by building a chat server. Okay? So I've got this guy, and I've actually got some code in here I need to comment out real quick. That's this code. Edit. Outlining. Where did it go? Advanced. Comment. Okay. So now I'm going to load this up one more time. Sorry. I'm going to hit run here, and we'll get this site running. And I'm going to do another guy, and we'll say Brady over here, and Scott over here, and Scott's going to say something, and you're going to see all that happening. And that's all well and good, right? Pretty cool. You've seen this before? Not too sexy? All right. Now what I'll do is I'm going to scale it out. So I'm going to leave the code the way it is. I'm going to pin this out. I'm going to grab my directory. I'm going to get get my directory. All right. The reason I'm going to do that is I'm going to go over here, and I'm going to run IIS Express from the command line. Okay? So IIS Express, path. Oh, that's not right. Path that in, port 8081. Boom. Now we're hosting that site that I just showed you on port 8081. Now, I'm going to open up a second one. I'm going to type IIS Express, path, port 8082. I'm going to host it over there. Run it. Now, I'm going to open up one web browser, open up another web browser, and I'm going to deliberately fail the demo. 8081, 8082. And you'll see that these guys are both getting requests. See here? And I'll type Brady G. I'll type Scott. I'll say, hey, dude. Why is that happening? Because I'm hosting it on two different servers. So I'm hosting this guy on two different servers, and they're not tied together with a backplane. Really quickly, just so you can visualize this, what I'll do is I'll open this guy up, and I'm going to scroll down to this slide and run this slide. So here's a backplane in action. Hubs do not share data if they're only running by themselves. Hubs by a backplane do. Okay? So if you have a backplane back here, Redis, SQL, Windows, Azure Service Bus, whatever you want to have, you can basically send a message in. That backplane will bounce the message out to all the other servers. In the case of the Service Bus implementation, what Clemens does, Clemens Vaster is the guy that, he's kind of in charge of that world. He wrote his own implementation. Clemens loves SignalR. He thinks it's awesome. He writes all kinds of things for it all the time. It's pretty groovy. Somebody at his level can actually get into something as open source as SignalR and actually make it work with his stuff. That should be some sort of evidence to you that it's cool. What he does in his implementation is he will actually give you the ability at runtime to shard messages across multiple topics. So rather than just have one topic into which all your messages go, let's say you've got big messages and you want to have crazy throughput, you can create 4 topics. And every message that one of the hubs sends will be split into 4 pieces and sharded across those 4 topics and then put back together on the other side again. Only Clemens Vasters could come up with something like that. It's crazy. Okay? It's a beautiful idea. But the throughput is amazing. You get thousands of connections all at one time. I just want to show you that visualization, because now what I'm going to do is I'm going to go over here to this Redis guy. Before I do, I want to open up one more instance of the browser. I hope I'm not boring you guys so much that you're leaving. So I want to go to github.com and then go to MS OpenTech. MS OpenTech is the Microsoft Open Technology subsidiary that we created recently to do all of our open source stuff. And you'll see right here, there is a Redis implementation, Redis on Windows. All you do is you do a git pull all that stuff down, you compile it, and then you have a Redis console that you can run right on your desktop. Right on your desktop. If you wanted to throw a VM up in Azure and run it out there, well, now you've got one out in the cloud, and all your guys can talk back to it if you wanted to. It would work similar to the Service Bus implementation. Okay, so I'll close that down. I just want to show you where to get it. What I'm going to do now is kill this process. I'm going to force kill it. Do the same thing over here. Die. Okay. And now I'm going to go over here to this Redis icon, and I'm going to click this. And this is Redis running on my computer. And it's just a shortcut that goes to the Redis source code folder where I compiled everything, and it's all hot and ready to go now. Now what I'll do is I'll go back over into my code. I'll go into my global file. You guys remember the shortcut key for uncommenting? There we go. Control E, Control U. And what I'm doing is I'm saying global host.dependencyresolver.use Redis. That lives right here. It's basically an extension method that hangs off the dependency resolver. Can't get much easier than that. You just pass in all your parameters and you party. You're ready to go. The nice thing is, you do the same thing with the Use Windows Azure Service Bus. I've got a Service Bus guy out there. There's my key. Feel free to overload my Service Bus account now. And then there's the prefix that I pass it. And this guy, you could increase this when you want to dramatically increase the number of shardings that you're doing. I'm only going to shard across one. If we get to that demo, we might not. We've only got about 5 minutes left. But the first one that I'm going to do is I'm going to run this and use Redis. So I'm going to compile this code real quick. I'm going to close this browser. I'm going to open this console window. Open this console window. I'm going to bring them down here. Wish there was a way I could reset that, but oh well. Can I scroll down? Okay. So now we'll do this. Go ahead and wake him up. Look what happened. I want to hit refresh. Hit refresh over here. I want to do a control refresh because I'm paranoid. I'll do Brady G. Over here, I'll log in as Scott. I'll say, how you doing? I'm pretty happy the demo worked. Now you see how to scale SignalR when you've got a web farm. We've got 2 servers. Those servers use a common backplane. In this case, that backplane is Redis. There's a website that you can go to if you don't want to download and compile Redis yourself called redis2go.com. And you can set up your own implementation. And I'm going to kill this, which is going to do interesting things to the servers. I'll go ahead and kill this guy as well. And now what I'll do is, just so you can see how it works, what I'm going to do over here is I'm going to go to my Server Explorer, and it might not actually show us this. I'm going to open up my list of topics in my Service Bus. And now I'm going to select this guy. Now, here's the caveat that I mentioned earlier. If you want to use the Service Bus implementation of the backplane, you must be running as a cloud service or a web role. Currently, that's how it works. The code makes the assumption that you're running as an Azure cloud service or web role. You can't just push this up to Windows Azure websites and party. It doesn't work that way. It doesn't work that way because it looks at the role environment and figures out which instance you're coming from. I've talked to Clemens about that. We both agree we'd like to rectify that problem, but we haven't gotten around to it. We've been doing these things. So what I'll do now is I'll select this cloud project, hit F5, and it's going to spin up the compute emulator. And I will point out that the first message I send will probably be dropped. I don't know if that's by design or if that's accidental, but I think what it does is that first call, it has to create the topic on the fly. So it'll light up the topic, and then the second call that it makes, it'll actually send the topic through. So I'm going to log in as some user over here, send a message, and see how it doesn't come through over there. I'll send another one, and there it goes. I'll type one over here, send a message, and it's going to come through. Now these guys are chatting using the Azure Service Bus backplane rather than the Redis backplane. So if you're a Service Bus fan, you've got that option as well. Now what I'll do here is I'll refresh this guy. Of course, it's not going to refresh. I could log in. That always happens. I could log into windowsazure.com. Let me try that. I'll log into the portal. Oh. I'm actually going to log into the Silverlight portal because I want to show you the topics get created. Maybe we'll have time. If we don't, feel free to leave. I'll go to the Service Bus. Click on the Service Bus guy right here. My node will eventually pop up, maybe. And you'll see that I've got Brady G, right there. And I've got one topic. What I'm going to do real quickly is I'm going to increase this to 5. And what I'm going to do is I'm going to open up this guy, open up the role, and I'm going to scale this to 4. So I'm going to host this on 4 instances, and I want to create 5 topics for each one. So I'll go ahead and run it. And this is just so you can see what you could do. This is my last second. Time's officially up, but I promise you that I'm really done. As soon as you see this demo, I just want you to see the power of what Clemens has created, because I promised him, and he's a lot bigger than me. So I'll run this guy, and he's not happy because his team lost last night. Okay, I did something wrong. Let me try it again. Terribly sorry. Oh, I'm not running as the cloud role. Sorry to take your time. I think lunch is next anyway, though, right? What will happen is when the SignalR client makes a connection to the backplane, what it's going to do is it's going to basically, and I'll open up my compute emulator so you can see this. You'll see that I've got 4 instances running on my site right here. And I've told Service Bus to create 5 topics for each guy that I pass in. Maybe it's not working. Okay, if I go back over here, I do a refresh on this guy. Check that out. Crazy sharding action. Thank you guys for coming. Please remember to do your evaluations. Tell me how I can do this talk better. This is my favorite talk to give, and I just want it to get better and better.